Good morning, sir.
Hey, good morning.
Yesterday I started with the videos, sir.
Okay,
I finished up the first video.
good.
Those Lorem's and Emmets were pretty new to me.
Okay, nice. How did
Not
you like it?
before. Yeah, it was very good.
Okay, that's nice. Did you get a chance to check other extensions as well?
Uh, I'm trying to see those. I've started the second video.
All right.
Sir, I had a question with the chocolatey part.
Okay. Can
Is there are
can
any more utilities which we can use for that?
I don't yet. I think there are, but then um, that I'm not familiar with those. But then as you move into the Azure DevOps world, you are going to use more and more utilities. So there's
Okay.
something that's going to come up in week 5, week 6. Probably we can share it at that time, or probably you can search it on the internet. But
Okay.
then yeah, there are definitely more than that.
Okay.
Okay. All
Yeah.
right. So it is about time that we get started. So we're going to start with a quick round of the overview of a lot of things that we have seen in databases so far. So we started with computers and how storage has changed, how storage has started all this technical work. So when we started using computers, the data was being saved in the form of files, and in those files they lacked relational consistency. Two files can have two different versions of the same data. A scientist identified the set theory and started applying the concept of set theory into storing values. They are called attributes. Attributes are something that we call values, and we started using in a tabular format. We only use the relevant information that makes sense to us. One of the doctor called Dr. Card's rule was that we should have an English-like statement, sentence that is going to give us what information we want to extract, from where we want to extract, and what kind of filters we're going to have. The language has a progression from Square to SQL to SQL, and SQL is more of a declarative language. Then we saw that what are scalar and non-scalar values. Scalar values are something that can be sorted, non-scalar cannot be sorted, and they should be divided into sets of their own. Another Dr. Cord's rule was that we should have a DBMS, a database management system, which is going to protect and serve, protection being the first priority, and it is going to guard the data from when multiple users try to access it and manipulate it and modify it. Then we talked about Docker. This is how I showed you how to install MySQL. That's an easier way. If you don't know how to get that running, you can install SQL Server on your computer and get going as well. Uh, we saw data manipulation language, which is SQL, select, insert, update, and delete. Then we saw DTL commands, which is the create and the alert command. There are other commands in DCL category, which is like grant access, revoke access, uh, dealing with permissions and things like that. And then there are data transaction language, and transaction is about committing permanently to database or rolling back when the transaction fails for any reason. Then we looked at the asset properties. Asset properties are extremely important for databases. It is atomicity, consistency, isolation, and durability. Atomicity is an operation should be performed as a single unit. Consistency is that the database should not be left in an inconsistent state. A transaction should complete all the way or roll back and fail for everything. So the database should be in consistent state. Isolation is grouping tables together so that when it is getting accessed or modified, the read should not give false information to the one who is trying to access. So that is going to be isolation, and durability is it is going to persist across crashes and across server restarts. Then we looked at entities and how to identify those entities. We look for recurring words and then repetition of such words like members, like member is calling, member is booking a code, member is paying fees, renewing membership, things like that. That is going to definitely make it an entity. There are other techniques to identify entity as well, which I would encourage that you go and read. Generally, the statement that you're going to get just 1 second. All right. So generally, the statement that you're going to get is an English-like sentence, and you should break up these English sentences into facts, constraints, and examples. This is going to help you identify or draw the entity relationship diagram. A circle indicates a parent entity. A diamond indicates an optional entity. If there's no diamond, it is probably it has some relation and no values are not allowed. The number of values that you want, you can specify here, and then you would generally want to decorate the line itself with the relationship, the type of relationship. Then we saw examples of data and the repetition of data. Um, this repetition is fine, is valid, because databases, they are created for storing fact, and Dave likes red color is a fact. With that, we figured out multiple ways of dividing column and how to identify if the information belongs in one table or we should go on separating into tables of their own. Depending on how you want to use the information, it is okay to store full name or divide it into first name and last name, or the first name initial and first name as a separate column. It all depends on one question, and that is how do you want to use the data. Your data generally starts in an unnormalized way. By applying techniques like the first normal form, second normal form, third normal form, you start normalizing the data. The reason you would want to do that is because one type of information belongs at one spot, and if modifying or deleting entries from there is going to affect other application or losing different type of information, then probably your data is still unnormalized. By applying these rules, you can add primary keys, you can divide columns into more atomic columns, and you can also identify if one entity, member of a table of an entity is getting identified by a non-key member or a non-primary key member. And when that happens, you try to extract out a new table, and these tables, they are going to give you a better design, a better connectivity, better relationship between these entities. Once you have the data normalized, you apply concepts like denormalization, where you take joins, and then using these joins, your data extraction becomes very logical, and it is ready for analysis. Right? Then we saw examples of denormalized structures and how they fit together. Then yesterday we started with NoSQL. Now, uh, NoSQL is probably not the correct name. Uh, its name should actually be no relations or no rel database. Everything that we discussed above is about relational databases. So two entities, they're definitely going to have a relationship. And then this is an example of that you have a customer and you have an order. When a customer places an order, you are going to store the customer ID inside the order table, and that is going to establish that relationship. So if I want to find out which products I bought, I'm going to take my product ID and I'm going to go to the order table and I'm going to query it for the customer ID with uh, that I have. This information is going to give me the result, but then that is not how you would always want to store information. Suppose in two different regions, people have two different ways of storing information or having addresses. So some places would say there's a city, there's a state, and there's a country, and others might say that there is a village and there is a county and there is a zip code, right? So depending on who your customers are and what standards they follow, your your tables, they are not always going to share the same relationship, or they're not always going to have the same attributes that you would want to store. And if your attributes are different, so should your data structure be. So the idea is that without defining any column, any structure, any schema for the tables that you're creating, you are just going to store key value pair. And then this key value pair is going to give you flexibility in terms of uh, the the storage that you're going to have. And then there becomes empty spots, which are, I mean, which don't exist, but you don't even need those um, spaces. So so each entry in the table is going to have a different schema. Of course, there's going to be some commonality, but then it is something that you will have to define every time. Places where you're going to use this information when you're storing something personalized, when you're storing documents, when you are storing information which could be different for different people, and you don't want to enforce any relationship, or the relationship is kind of not a good candidate for a relational database. Then we looked at the CAP theorem. Okay, before that, we also discussed a case where a relational database with hundreds of tables is going to have um, a performance lag because of its structure. NoSQL databases, they are created for web, and their performance is generally extremely good for publishing sites, for sites that have a lot of data and does not require a lot of querying and taking joins between two tables. With that, we looked at the CAP theorem. Yesterday, I had put relationship here, but then it is actually partition tolerance. So CAP stand for consistency, availability, and partitioning. Now, this is a tension diagram. A tension diagram is something that you will have to pick two, and then the third is going to be compromised a little. Um, when you are working on transactional application like stocks and banking, where you would always want the right amount, the right quantity represented, you are going to lean towards the relational database. But when you are okay with a little bit of delay in data synchronization across multiple servers, multiple places, locations, you're going to lean towards NoSQL, because NoSQL, it guarantees it does not guarantee consistency right in the beginning, but then the term is eventual consistency. So as soon as you make a change to database, it's going to make sure that eventually after some time it is going to be distributed to all the databases in the system. And the availability of NoSQL is very high. So it is very crash tolerant. And if servers go down, the system is always is still up and running. Right? Then this was the example of the places of having a database server at two different locations. Then we talked about distributed architecture, and the word that we used there was sharding. Sharding is a strategy where you have a million, if you have a million rows, you're going to divide it into consumable chunks of say 200,000 rows each, and you're going to put them across 5 different servers. So this is a strategy, and you're going to come across this as you work on more database heavy applications and distributed databases. One common thing among most of the NoSQL um, implementations is that generally they are not going to have a query language. So you won't be writing any select statement like this, but then there are exceptions to this. They have different mechanism about which they can go on extracting the data. Right. Then we saw an example of MapReduce when you have a massive amount of data to process, such as counting the population of a country or identifying how many cell phone users are there. You are going to divide the entire job into multiple small consumable, processable data sets, and you're going to process them individually on different commodity server. Now, a commodity server computer is a computer that probably we use at our places. Uh, MapReduce or technologies like big data, they use those commodity servers in larger chunks, like hundreds and thousands of them, and they process small amounts of data at their individual spots, which is called mapping. And then this mapping then eventually gives you a processed set, which is then eventually combined to get the final result, which is the reduce operation. So a lot of NoSQL languages, they're going to give you an option of doing map and reduce kind of functionality. Once again, what we saw about the SQL language is that it was declarative, but then NoSQL is a little bit like programming. So you will have to give specific expressions that are going to put this information together, like take a chunk and then come out of with some process information. So that is going to look a lot like a programming language, and the reduce is going to be something similar. Then we looked at 4 different categories of NoSQL databases. The first one is key value pair. It looks a lot like the JavaScript object. A key on the left, sometimes it is in the double quotes. Some languages, um, some implementations are a little forgiving, and they are okay if you don't put this in the double quote, but then it is always going to be a key and a value pair. Key on the left separated by a colon, and the next one is the document store. In a document store, everything is a document, and MongoDB and CouchDB are example of that. We looked at CouchDB in a little depth yesterday. Once again, all these databases, they are not going to have any schema. So each row, each entry in the database can have its own key value pair set.
Hello, sir.
Yes, so is this?
So sorry to interrupt, but
Sure.
Bhakti Nimbalkar has some issue to join the meeting.
Okay. All right, guys, give me 5 minutes, okay?
Okay.
Hey guys, let's do one thing. I think Bhakti is having some difficulty joining. Let's end this call here. I'm going to ping you a new link on our WhatsApp chat, and can everybody join on that new link?
Sure, sir.
All right. Thanks.